Hi, uh, welcome back to the channel. So today I'm going to show you how to scaffold a Golang application following one of the most used architectural patterns in production systems right now. So this is a modular monolith. So modular monoliths are the way people build MVPs, and the reason why is you get to scale each module individually as need arises, so it avoids the initial complexity. It also benefits from the good side of microservices, in that you could always separate modules and then scale them independently, and benefits from the modular side of monolithic side of things, in that you deploy one database maybe with different schemas if you choose to. In our application we are going to choose to have different schemas and different database. Your deployment pipeline will be one. So an example of application that I've scaffolded here is a food delivery application. So I'm calling it Campus Eats. So it comprises a mobile app. Our modules will be order service, restaurant service, payment service, delivery service, and then the invoicing service. So how does this look like? So all our shared code will be in the internal package. So we load our configs package inside the internal. We load our config here. We have our global logger. As you can see it's here. And then we have our monolith package. So this is a package of interest. So every module in this collection of modules that we are calling a modular monolith will have to implement this interface. So it should have a config, database connection, a logger. We are going to have a combination of REST API and gRPC API endpoints. And for our client facing interactions, we are going to use REST. So an example would be when a customer comes and then they place an order, that will go through the REST API. But then internally, we are going to use gRPC for module to module communication. So an example after let's look at our flow diagram. So when this is when the order service has been created and the order has been validated, we are going to reserve inventory. Inventory lives inside the restaurant service. So this is going to be a gRPC call. So our module to module calls will be gRPC, and our client facing APIs will have REST endpoints. So each and every module will implement this. And then if we come to our RPC, right now we only have the configs, or we could have, let's say we are doing something like monitoring and logging and observability. We would wrap all that functionality here, because this is the all modules that will communicate via gRPC will have this in common. We have our utils package. So in our utils package, these are migration, how we do migrations. So we are doing migrations from embedded migrations files in each module. So that's why you see we are reading the migration documents from our file systems. So I'll show you an example of how that is happening. And then we have this waiter package. So this is the orchestrator of our system. So let's say when the system is starting or when the system is shutting down, it makes sure that all processes that were ongoing are completed before it shuts down. So an example is when the system would be shutting down, when you shut down the system when an order was already created, it will wait for that whole order life cycle before the system shuts down. And also it modules startup times. So all the modules will be stacked on our waiter, so that we make sure that the whole application is starting at the same time. So let's see our main.go file and see how this is happening. So we have functions that initialize. This will initialize our REST API endpoints. This will initialize our gRPC servers. And then you see here we are adding the web and RPC to our waiter. Also, you can see here we are adding our modules, and then we are calling the startup module function. So what this startup module function does, it ranges over all the available modules and then starts them up. So module startup function should be this. So each and every module has to implement this interface, the startup interface. So in my scenario, I've done the payments module, and we can take a look at the payments module. So I'm using SQL-C to generate CRUD for Go code for our database interactions. I'm using BAF to generate gRPC stub functions. So let's take a look inside our module and see what's happening. So we have a struct here called the module. This is the payments module. As I told you, it needs to implement the startup interface. So we pass a context, and then we pass the monolithic interface that we also defined here. So this monolithic interface, like, it will contain things like the database. These are the things required for that monolith to run. Excuse. So we were here at the module. So our payment module only requires a payment store, and then we set up the application, and then we run migrations. We are running schema level migrations. As I showed you here, we are using our utils package to run this schema level migration. If you go through this code, you'll see that we are passing the module name to the connection string, because we want to make it easy to migrate our databases. Let's say even the payments module needs to process a lot of payments, so we are migrating it out to be a standalone service. We'll have to migrate the data. So having it in that we use different schemas for every module, I think it's just good practice. So in our so we have the REST endpoints. So this is the Swagger API. If you find this useful and you want to know how to generate this is the documentation for your backend. So you can, the API endpoint to create payment, and you get an invoice and pay that invoice. You can ask down there, and I can create a whole video on how to generate this for Go application. For frameworks like Fast API, it's always done automatically, but Go shines for this microservice type of things, and also because it's a compiled language and you only have to ship a single binary most times. And it's as easy, like Golang is as easy as Python, so development time is not compacted, and it comes with all the benefits we get from compiled languages. So I think it's a good language, and if you're writing backend APIs, you should really know how to document them. So you can comment below, and then I can work on providing a tutorial on how to create this with Golang. So our application interface is here. We can authorize payment and then confirm payment. Our generated code lives here. So this project is still in its very early stages, but I think the payments module is almost done. I can show you the live documentation and a trial. Let me open my browser and we go to localhost and then see. Yeah, this is the API documentation for it. We can go to payments. Let's try it out. We can execute and yeah. Okay, so our database, you see we are getting an error here because we are sending 0 value, and the database checks that for us. So you see our payment successful, and let's see if we can test our customer creation. Let's see, we need a customer name and a number. Try it out. Yeah, our customer is created successfully, and we can disable our created customer. Let's pick their ID and disable them. Oh, I get an error, invalid UUID length. I think I will debug that, and I don't know. Let me see. Did I copy it fully, or it was? This is the customer ID that we got. Yeah. Oh, I copied it wrongly. So if we execute, you see we get that, and our customer is disabled. Yeah, like enabled customer. Oh, let me see. Oh, it needs to be disabled. Oh, no. I was working with enabled customer. Oh yeah, to disable a customer you call this other one, and so you see our disabled customer is throwing an error, customer already enabled. So these are just bugs that I will fix moving along the way, but I was just showing you how this is standalone. Like, let's see our customer. Let's try out. Oh, we already tried out our customer API endpoint, so this is coming along well. I will show you the finished product if this one can get good traction. And yeah, so just a recap, every module here is independent, its own database schema, its own migration files, but then we have an monolithic interface that all other modules implement, and then we just plug them and range. We just create a list of them and then we range over them when we are starting out to build this. So basically it. So thank you for listening, and